In this episode, we're going to look at how to configure numbered standard IPv4 access control lists. I'll show you how to do it, and we'll talk about those concepts along the way. Standard access control lists are router configuration scripts that control whether a router permits or denies packet based on a source address. This activity focuses on defining filtering criteria, configuring standard ACLs, applying ACLs to router interfaces, and verifying and testing the ACL implementation. Our routers are going to be already configured, including IP addresses and EIGRP routing. We'll be discussing how to plan an access control list implementation, including configuring, applying, and then verifying our standard ACL. Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Packet Tracer Lab 5.1.8. Configure numbered standard IPv4 access control lists. Here I have our packet tracer file open. On the left side I have our work area that has our topology. That's where we're going to do our configuration of our devices. On the right side I have the instructions. For this lab, I'm just going to use the packet tracer activity window that opens up when you open up packet tracer. No need to have a Word document because there's no questions to answer. We can see our topology here. We have 3 routers in the center, and then there's some switches connected, and finally we have some PCs or servers at the ends of those switches. We have our addressing table over here. This is how all of our devices are configured, what IP addresses, the subnet masks, and then if they have a default gateway or not. Down to our instructions. Part 1, plan an access control list implementation. So investigate the current network configuration. Before applying any ACLs to the network, it's important you confirm that you have full connectivity. And what we're going to do is we're going to ping our devices, but I'm going to selectively ping. I'm going to choose PC1 right here, and then I'm going to ping the far devices sort of on each leg of our network. So from PC1, I'm going to ping PC2. From PC1, I'm going to ping PC3. And then from PC1, I'm going to ping the web server. If I can ping all of those, that means I can navigate our network correctly. I can get through all the devices. Our configuration should be set up and ready for us. So I'm going to click on PC1, slide it over, make sure I'm on the desktop tab, and click the command prompt application. From here, I'm going to go ahead and type in ping, and then I'm going to scroll up to our addressing table, get the IP address for PC2, which is right here, 192.168.11.10. I'm going to go type that in, 192.168.11.10. Well, looks like we're going to fail the first echo request, but then the next 3 worked. I'm guessing once again that echo request and waiting for the echo reply to come back timed out because we had to do some ARP lookups on the way through. I'm going to repeat the command just to make sure it works. So I hit up arrow once and hit enter. All 4 pings came back correctly. I'm going to ping PC3, 192.168.30.10. 190. So start off with the word ping. So ping, and then 192.168.30.10. Hopefully, once again, we're doing some ARP lookups. So the first request timed out, and the next 3 worked. I'm going to verify that, hit the up arrow once, and hit enter. Make sure that all 4 pings work this time. PC1 is able to ping PC3. And the last one I'm going to do is ping from PC1 to our web server. Here's our web server at 192.168.20.254. So I'm going to go ahead and ping that address. Ping 192.168.20.254. Most likely we'll have to do an ARP lookup. So the first ping should fail. Next three worked. I'm going to go ahead and repeat that. Up arrow once, hit enter. All 4 pings are going to work. So we have verified we have connectivity from end to end on our network. That takes care of part 1, step 1. On to part 1, step 2. Evaluate 2 network policies and plan access control list implementations. The following network policies are implemented on R2. The 192.168.11.0/24 network is not allowed to access the web server. So here on R2, the 192.168.11 network, which is PC2 down here, PC2 and the network it's on, is not allowed to access the web server. So we have that up here. All other traffic can reach the web server. To restrict access from the 192.168.11/24 network to the web server without interfering other traffic, an ACL must be created on R2. The access list must be placed on the outbound interface to the web server. Up here on R2, we want to place that access control list right here on the interface that goes to the web server. If I click in this window, mouse over this triangle, we can see that it's gig 00. So on gig 00, we want to put that access control list. A second rule must be created on R2 to permit all other traffic. Once again, we have to permit something through our access control list. If we don't permit something, it's going to be denied, because we have to have that permit, because that last one, after we go through all the access control entries in our access control list, each one of those lines, if nothing matches a permit to get through, that last line is that implicit deny. We deny all traffic on that access control list at the end. Then step 2B. The following network policies are implemented on R3. R3 is right here. The 192.168.10.0 network, that network over here where PC1 is on, to the 192.168.30 network to where PC3 is. So PC1 to PC3 is not allowed to, or sorry, the 192.168.10.0 network is not allowed to communicate with that 30 network. So any PCs on this network over here on the bottom left is not allowed to communicate with any PC over here on the right. All other access is permitted. That's where we have to make sure we permit that traffic to come through here. To restrict access to from the 192.168.10.0 network to the 192.168.30.0 network without interfering the other traffic, an ACL will need to be created on R3. The ACL will be placed on the outbound interface of R3. So right here, we're going to place that outbound ACL. A second rule must be created on R3 to permit all other traffic. Takes care of part 1. On to part 2. Configure, apply, and verify a standard access control list. Once again, a standard access control list only looks at the source IP address. It only looks at the source IP address. An extended looks at source and destination IP address. It looks at TCP, UDP. It looks at what layer 4 it's working at. And so you can filter more granularly on an extended, but right now we're going to create a standard where we're only looking at the source IP address. Step 1, configure and apply a numbered standard ACL on R2. Create an ACL using the number 1 on R2 with a statement that denies access to the 192.168.20/24 network from the 192.168.11/24 network. So on R2, I'm going to go ahead and click on R2 right here. Brings up my window. I make it a little bit bigger going right to left so it lays out better when the text shows up on my screen. We only have one tab here, the CLI, so we're good to go on that one. No password, so I hit enter, brings us right in there, so I can go ahead and type enable, brings us into privilege exec mode. Now, to create our access control list and add access control entries, we need to be in global configuration, so go ahead and type config T. Now we can go ahead and enter in our access control entry for access control list 1. That starts off with the keyword of access dash, okay, I spell access correctly, so access dash list space, and then the number of our access control list. We're going to use 1. And then we need to deny access, so we're going to have the keyword deny, because right here you could put deny permit or remark. We're going to deny traffic, and then once again we're looking at the source address, so it's from the 192.168.11/24 network. So 192.168.11.0 network, and then it has the subnet mask here. But when we create an ACL, we need the wildcard mask. It's the inverse of that subnet mask. The ones and the zeros are inversed. If we look here in a subnet mask, we got 24 ones followed by 8 zeros. If we invert that for our wildcard mask, that will give us 000.225. The other way to convert it from a subnet mask into a wildcard mask is put 255.255.255.255. So you got 4 255s, then put your subnet mask in dotted decimal notation below it, so that'd be 255, 255, 255.0, and then you subtract the top from the bottom. So in the first octet, you'd have 255 minus 255, that would give you a 0. Second octet, 255, 255, that would give you a 0. Third octet, 255 minus 255, that would give you a third 0 in the third octet. And then in the fourth octet, you have 255 minus, and the subnet mask had a 0 in that fourth octet. So 255 minus 0 gives us 255. 3 zeros when we subtract the 255 minus from 255 in the first 3 columns, and then dot 255, that was 255 minus 0. So 000.255 is our wildcard mask. 0.0.0.255. Okay, that creates it, that denies that traffic, but then we have to permit everything else, and that's what we're doing here in step 1B. By default, an access list denies all traffic that does not match any rules. To permit all other traffic, we have to create a permit statement. And so we start off with access list, this access control list, this access control entry we're creating belongs to access list, and then 1 again. And here we want to permit, and normally you put the source address in here, but we want to apply we want to permit everything else to go through this connection. And so what we can do, we could put quad 0 in there, or we can use the keyword of any, ANY. And that'll permit anything. If we look back here, the first access control entry in our access list 1 here will get executed. If it matches this network with this wildcard mask, it will be denied. If it doesn't match this first access control entry, it'll go down to the second one, and it'll permit anything that makes it down here. And if for some reason it makes it past this, then it goes into the implicit deny where it gets denied. But this second statement will allow it to go through. Now, to verify this, what we can do is enter in a command, but we need to be in privilege exec mode, so go ahead and type exit once. Now, to verify it, we can do a show space access dash list command, and it'll list it out. Here it says we have a standard IP access list with a number of 1. These are our sequence numbers. So sequence number 10 here is the deny from the PC1 network, the bottom left network with its wildcard mask. Sequence number 20 is permit anything else. We didn't have to put the 10 and 20 in. The operating system did that for us. Now, once we created it, we have to actually apply it to an interface. We are applying it to, once again, we're working up here on R2, and we're going to apply it to the exit interface that's going to the web server. That would be right here. We are looking at, so I click in the window, I mouse over to triangle, we're going to apply to gig 00. Oh, I got a new adjacency. We had some systems going up and down here. But we can just hit enter and not have to worry about that. And so we have to go into that interface of gig 00. From our privileged exec mode, we can go ahead and type config T, brings us into global configuration mode. Then now we can go into interface space G0/0. So we're going into gig 00. Our prompt now changes saying we're in interface configuration mode. And right here is where we're going to apply that access list. And so this is dealing with the IP suite. And so what group of access control entries are we going to do? So our command here is access-group, and then you put in that number we created. Up here, it's access list 1, or you can look at the directions in the lab, but we have access list 1 right here. And so that's what we need to put right here. We need to specify what access list it is. And then finally, we need to specify a direction. So I put a 1, I put a space, now I put a question mark. And so we either need to say inbound packets or outbound packets. And we want to look at the packets that are going out of the gig 00 interface. So we can go ahead and type out, and it applies that access control list to outbound traffic on gig 00 here on R2. Part 2, step 1 is done. On to part 2, step 2. Configure and apply a numbered ACL on R3. I'm going to go ahead and minimize this. Once again, here's R3. We're going to create the ACL on the interface that's going down here to PC3, and what we're going to do is we're going to block traffic from this bottom left network, the 192.168.10.0 network, and stop it from entering this network here, the 192.168.30.0 network. To do that, we go into R3 here, make the window a little bit bigger, going right to left. Hit enter, type in enable to get us into privilege exec mode, and then config T to get into global configuration mode. Create an ACL using the number 1 on R3. So we're in R3, we're going to use the number 1 as our ACL. Denies access to the 192.168.30 network. And once again, this is a standard ACL where we need to look at source addresses. So we're going to this one. This is the destination, but it's from PC1, and PC1 is on the 192.168.10.0 network. This is the address we need to use. And once again, this is a /24 subnet. And remember, a /24 subnet is going to give you a wildcard mask of 000.255. So in global configuration mode, we can type in access -list, and then we're using access list number 1, and we're going to deny that traffic from the 192.168.10.0 network and put in our wildcard mask of 0.0.0.255. That creates that'll block traffic from the bottom left network getting onto the bottom right network. Then we have to make sure we permit everything else. So we go into access-list, and then it's once again, it's the same access control list. It's number 1, but this time instead of denying, we're going to permit. So permit, and we're going to permit everything else. Anything else that doesn't match that first access control entry, we're going to allow anything else through. we could put 2 quad zeros in there, but instead we're going to use the keyword of any. So anything will be permitted through there. Let's see. And once again, when you type in something wrong in the Cisco world, it will tell you. Right here, it said an invalid input detected at the marker. Here's the marker. It's pointing up right here to this character, and I spelled list wrong. I have L-I-A-T instead of L-I-S-T. So I need to correct that. I hit up arrow once, left arrow over, change that A to an S. There we go. And with the Cisco operating system, no news is good news. If I did it correctly, Cisco's not going to tell me. If you did it wrong, like I did previously, it will let you know. So I have my 2 entries in my access control list. Let's go ahead, confirm that we actually have that. Go ahead and type exit once. Then once again, the command to show us our access list is show space access dash list. Here we have our standard IP access list number 1. Sequence number 10 is the deny from the bottom left network. Sequence 20 is to permit anything else. Exactly what we're looking for. Next step is to apply it to an interface. I'm going to click in this window, and once again we're on R3 right here, and we're looking at we're filtering traffic onto this network. And so the interface we want to apply it on is the out interface right here. So I clicked in this window, I moused over the green triangle, and it's telling me we want to put it on gig 00. So if I want to put it on gig 00, I go into global configuration mode. I go into the interface of gig 0/0. And then from here, I can go ahead and I can apply that list, or that access control list, that group of access control entries. The command to do that once again is IP, because it's part of the IP suite. And then it's access group for that group of access control entries. So IP space access dash group, and then what number access list we're working on. We were working on number 1, and then finally what direction we want to apply to all traffic going out the gig 00 interface. So we put in the word out. That gives us completion of step 2. On to step 3, verify ACL configuration and functionality. Enter the show run or show IP interface gig 00 command to verify ACL placements. So I'm going to go ahead, click on 00, or sorry, I clicked on R2. I'm logged in here, type in exit, and what I'm going to do is I'm going to do a show space running config, or just simply a show run. And then I'm going to go down until I see information about my access control list. First thing I'm looking at here is my interface of gig 00. Here we can see IP access group, the group of those access control entries for access list 1 is applied to the out interface. That's what we're looking for. Then I hit spacebar again, brings me down a little bit further. I have access list and then the number, and then we have a deny statement in there. So this is our first access control entry in access list 1, where we're denying traffic. And then the second one, we're permitting anything else that makes it this far. That's looking good for our access list. I'm going to go ahead and minimize R2. I'm going to pull up R3 here. I'm going to do the same thing. Exit out once, exit out twice, gets us into privilege exec mode. Go ahead and do a show running config, or simply show run. Take me down to the interface. Right here is gig 00, and we can see that we have access list 1 applied to the out traffic. If I hit spacebar again, brings me down to the actual access control entries in my access list 1. So here is the first access control entry, belongs to access list 1. We're denying traffic from the bottom left network to the bottom right network. And then if it doesn't match that, it goes down to the second one, where we permit anything else to come through. Those configurations, those look good. I'm going to minimize this. We're going to check it a second way. So back on R2, what I'm going to do here is do a show IP interface gig 0/0 and hit enter. Now, looking through here, we can see a bunch of information. Like, here's our IP address. A little bit further down, we can see that we have an outgoing access list here is number 1. And then the inbound access list isn't set. Once again, we are on interface G00 here on R2. We have an outbound access list of 1. We have an inbound access list that is not set. So we can verify what access lists are applied to the interface in what direction. Once again, you can only apply one access control list to an interface in one direction. So at most, you could have 2 access control lists per interface, one for inbound traffic, one for outbound traffic. Let's go ahead and take a look at R3 quickly. Go ahead and type in show IP interface gig 0/0. Once again, gives us some information. We're up and up. Here's our IP address, and a couple more lines down. We have the outgoing access list is 1. Inbound access list is not set. Exactly like we would expect to see. Takes care of step 3A onto step 3B. With the 2 ACLs in place, network traffic is restricted according to the policies detailed in part 1. Use the following tests to verify that. A ping from 192.168.10.10. Well, .10.10 is PC1. So from PC1 here. So a ping from PC1 to 192.168.11.10 should succeed, but I forgot the word ping. So up arrow once, left arrow over, type in PING space. Now I'm going to ping it. And so we're going from PC1 here to PC2. Looks like I had to do an ARP request just to verify it actually worked. Up arrow once, hit enter, all 4 are working. So we can ping from PC1 to PC2. We didn't set up any ACLs there on R1. That should continue to work. Next, ping from PC1 here to our web server. See if that succeeds. And so I'm on PC1 here. Go ahead and type in ping 192.168.20.254. Probably going to have to do an ARP lookup once for a timeout. Then all 3 worked. I'm going to just repeat that again. Up arrow, hit enter. All 4 is working. So that succeeds. Now, from 192.168.11.10, that is this network right here, ping the web server. And once again, remember, we set up the ACL right here on R2 on the outbound interface to block all traffic from the 192.168.11 network. So that should fail. PC2, open up our command prompt, go ahead and type in ping, and then the IP address of the web server, 192.168.20.254. And we're getting a message back saying destination unreachable. Our ACL is blocking traffic correctly. It is not letting it go through. And it's coming from 10.1.1.2. If we scroll up to our table here, 10.1.1.2 is actually up on R2. It's the serial interface. And so the serial interface right here, this interface is on this device. So R2 is saying I cannot get there. I cannot get to the web server. The host is unreachable. And we know it's because we set up that ACL to filter out traffic outbound on that interface. Looking here, then we are going to ping from PCA to 30. So from the bottom left network, we're going to ping from here to here. Once again, that should fail because we set up that ACL right here. We set up that ACL right there. So open up PC1 again. Type in ping and then the address of 192.168.30.10. That should fail because we had that ACL that's blocking traffic from PC1's network. Now what we're going to do is we're going to go from PCB right here and ping, PC2 and ping PC3. We don't have an ACL blocking traffic there, so that should succeed. I'm going to go ahead, type in ping, and then the IP address for PC3, which is 192.168.30.10. Hopefully we're just doing an ARP lookup here. One request timed out, and then the 3 other work. So we did an ARP request for the first ping. I'm going to repeat the command, up arrow, hit enter, all 4 works. And then finally, to verify our last one, we're going to ping from 192.168.30.10, which is PC3, up to the web server. So we're going to go from PC3 up to the web server. And remember, the only ACL we had blocking traffic was from PC1, so PC3 to the web server should work. Open up our command prompt, type in ping, then the IP address of our web server, 192.168.20.254. And all 4 worked. We didn't even have to do an ARP lookup that time. So it is working as predicted as we set up our access control list. Step 3B is done. On to step 3C. Issue the show access lists commands again on R2 and R3. You should see output that indicates the number of packets that have matched each line of the access list. Note the number of matches shown for your routers may be different due to the number of pings. We repeated those pings a couple of times, so we're going to have more matches. But let's go ahead and look at that. So on R2, I'm going to click on R2. And then the command we're going to enter in is show access-lists and hit enter. And we can see here we were denied from when we were on PC2. We had 4 denials, but then we permitted anything else, and we pinged from PC1, we pinged from PC3, so we had a number of successful matches there. Let's go ahead and take a look at R3. R3, we can do the same thing. Show access-list. And here we can see we have 4 matches for the 4 pings we denied from PC1 to the web server, and then we ping PC2 and PC3 several times to the web server. And so we do have several matches there. That was Packet Tracer Lab 5.1.8, Configure Numbered Standard IPv4 Access Control Lists. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.